Hi students, this is going to show you and explain how to solve a system using substitution. So for this first example, and again, I just pulled things out of your Check Your Understanding packets. This is a system of two different equations, and we are trying to find the one ordered pair, x comma y, that satisfies both of these equations. So I know that y is equal to x plus 3. So what I'm going to do is I am just going to substitute it in place of the y in the other equation. So I'm going to write this 3x, write this other equation, everything except I'm going to put in the x plus 3 in place of the y, because that's what y is equal to. That is our substitution. Once I do this, I can go ahead and start trying to solve. So this is a solving question we've done before. It's a little bit messy. The first thing I would recommend is to distribute. So we're not to the do and undo quite yet. Okay, so I just distribute that 4. The next thing I'm going to look at on that left side, I can actually combine the 3x and 4x. So I would get 7x plus 12 equals -2. At this point, we can do the do and undo steps. So if we want, the do steps would be what was done to x multiplied by 7 and then added 12. To undo, I subtract 12 and divide by 7. So I'm going to go ahead and show those steps. I subtract 12 from both sides. That is going to take this term away, so we'll have 7x equals -14. And now I divide both sides by 7. 7 over 7 is 1, and x equals -2. Now I don't want to stop here. I have to actually substitute that back in to find the y coordinate. Now my suggestion for this is just to pick the easiest spot to plug it in. And so I would go for this first equation because y is already alone. So I would write, instead of the x, you know what, let me write the whole equation first and then I'll show the substitution. Okay, so x plus 3 equals y. Those are equivalent. The x value plus 3 more is y. So I'm going to go ahead and substitute, instead of the x, I'm going to put my -2. Everything else is the same. And -2 plus 3 is 1. So the solution is -2, 1. And that's the solution to the system. Now, had you graphed the system, that's exactly where they would intersect. So either method, graphing or substitution, will give you the same solution. Now, how do we check a solution? We plug it in. So we're going to go into both original equations. So I'm going to start here. Let's see. X plus 3 is equal to y. Instead of x, I'm going to put a -2. Instead of y, a 1. And 1 does, in fact, equal 1. I'm going to check it in the other equation as well. We got to check it in both. So this one is 3x plus 4y equals -2. I take those from my originals. 3 times the x value, which is -2, plus 4 times the y value, which is 1, and that equals -2. So this is -6 plus 4 is supposed to equal -2, and in fact, it does. And so I know now that my solution, -2, 1, is valid because I checked it in both original equations. Be patient with yourself. This is definitely a longer process, so take your time and check your work. Okay, so I chose this example from Check Your Understanding because in this one, we do not have a variable that has been isolated. So in the first example, notice that this y was already alone. So we were able to go ahead and do the substitution. Now in this one, we do not see a variable that is alone on one side of the equation. So you have a couple of options. Personally, I would not really want to get the x or the y alone here because it's going to just be several steps. It's not horrible, but I still would probably pick the easier one, which in my opinion would be to get this x alone. Because all I would have to do to get x alone is to add 1 to each side. Now the other thing you could do is try to get y alone, and then you would divide both sides by 2. I still kind of like the x, so that's what I'm going to do, but you can certainly choose to do something else, and we should come up with the same answers. So to get x alone, I'm just going to undo the minus 1 by adding 1 to both sides, and so x equals 2y plus 1. This is what x equals. I'm going to put it in place of the x in the other original equation. So I'm going to write 7, and then I'm going to put in what x equals, which we just said is 2y plus 1. Those are equivalent. Minus 2y equals 1. And now I'm back where I was in the other problem, is I just need to clean up the left side. So I can see I can distribute the 7. 7 times 2y is 14y, and 7 times 1 is 7. And I just bring that minus 2y equals 1 along. I see I can combine like terms on the left side. And so I get 12y plus 7 equals 1. Now from here, again, your do steps, I'm just going to write them off to the side here, times 12 plus 7. That's what was done to y. To undo, to get y alone, I subtract 7 and divide by 12. So let's do those steps. I subtract 7 from both sides of the equation. And now I divide both sides by 12. And you will get a negative 1/2. So negative 1/2 is my y coordinate. So for my solution, it's going to be something comma negative 1/2. I don't know the x coordinate yet. Now again, I want to do this in the most efficient way if I can. And I would say let's plug it in at this point, because look at the x is already alone. So it's x is the same as 2 times the y value, which we just found, plus 1. X is 2 times the y value plus 1. 2 times negative 1/2 is a negative 1 plus 1, which is 0. So the point 0, negative 1 is my solution. Now, we always check to make sure that we have the solution correct. So let's check the green one first. That top equation was 7x minus 2y is supposed to equal 1. So I'm going to go ahead and substitute instead of x a 0, instead of y a negative 1/2. 7 times 0 is 0, and negative 2 times negative 1/2 is 1, and 1 does equal 1. So it works in the green equation, that first equation. Next, we'll go ahead and do the blue. 2y equals x minus 1. 2y equals x minus 1. Let's plug in what we think it is. The y value is negative 1/2. The x is 0. And so this is negative 1 equals negative 1. And it works out there as well. So now I know my solution is valid. It's a solution to both equations, and therefore is a solution to the system.